The question is the increasing order of ionic radii of the given isoelectronic species is. Now first of all, do you know what is isoelectronic species? What are they? The isoelectronic species are the ions where the number of electrons is the same. Right? They've got same number of electrons. That is, the nuclear charge differs. Right? Now students, more is the effective nuclear charge more will be the attraction for electrons. Right? What is the effective nuclear charge? It is the net force of attraction which nucleus has on the outermost electrons. Now, as the Z by E ratio increases, Z to E means Z is the effective nuclear charge, E is the electron. As this ratio increases, the size of ion decreases. This is in the case of isoelectronic species. Right? So, see, more is the force of attraction by the nucleus, more closely will be the electrons held towards the nucleus. See. Right? So, more is the force of attraction, smaller is the radius, or smaller is the size of the ion. Now, in this case, if I take, let's take up the Ca2 plus first. So, calcium ion, what is the number of protons in this ion? It is 20. And the number of electrons here is 18. Potassium ion, the number of protons here is 19 and electrons is 18 again. Then a Cl minus ion. The number of protons is 17 and the number of electrons is 18. Likewise, there is S2 minus ion. Here the number of protons is 16 and it is 18. So, which among these will be the smallest? In which case more nuclear charge is there? In the case of calcium. So, calcium ion will be the smallest among these. Then comes the potassium, then comes the chloride, and then comes the sulfide ion. Right? So, do remember this thing, students, that more is the effective nuclear charge. Obviously, that is the more is the net force of attraction. Smaller will be the radius of the ion. So, more tightly will the electrons be held. So, in this case, our right answer is C.